Hey, all you Chiefs fans and you closet Chiefs fans who think you're Lions fans but are going to become Chiefs fans when the Chiefs destroy the Lions this weekend. But anyway, today we're going to talk about integration by parts. And let's talk first about what this is, and then we'll do an example, and hopefully that'll help you as we get into class to talk about what this is. Okay, so integration by parts. Um, let's work a little backwards here. So let's say we have f of x times g of x. Well, you know that derivative is f prime of x times g of x plus f of x times g prime of x. Okay, so that's something you should know. But so what you should know is that integration by parts is kind of like the product rule for integrals, if you will, kind of like that, right? So um, let's do some work here. Okay, let's integrate. All right, we're going to integrate, so we'll put a dx in here. So that means we have to integrate here dx, and we have to integrate here dx. All right, and through the magic of television, we get this. So that doesn't look like much, but now what we're going to do is we're going to solve for this here. And when we solve for this here, I'm also going to switch these around here. And so when I do those things, what we end up with is this. So this is the integration by parts rule, all right, the product rule for integrals, if you will. Let me get that out of the way of the smart notebook. And so instead of writing it this way, what we tend to do is we tend to let u equals f of x and v equals g of x. And so what we do is we rewrite this then as u dv, that's this part right here, dv, equals u v minus v, and then this all together here is du, because it's the derivative of f, all right, where this is the derivative of g, right, dv. Okay, so this is the integration by parts rule. All right, we're going to use that a lot this year, and especially in the next couple of days in the class. So let's look at an example, and then you're free to practice this on your own. Okay, so let's take a look at this example here. The integral of x sine of x. Hopefully you recognize that there's no way to do a u substitution here. If we, it's kind of pointless to let u equal x. If we have u equals sine of x, then the derivative of that is cosine of x, but cosine of x isn't there. So let me come back here. Let me pull this. See if I can pull this out of here. All right, I'm going to pull this over here so that you can see what I'm doing. All right, let's put that there. All right, and so now what we need is we need to know what u and v are, or actually u and dv, sorry, u and dv. So let's let u equal x, and then dv equals the second part here, sine of x dx. Sine of x dx. All right, and then you know that v, hopefully we remember this, is negative cosine of x, and du just equals 1 dx. And so now if we start to put all of this together, this integral is uv, so negative x cosine of x minus, well, what's v? V is negative cosine x, so I'm going to integrate, or not integrate, I'm going to put the negative there. So this was a negative, and with that negative, it makes it positive. So cosine of x dx. And so now what's happened is oftentimes we do this, and they set it up well for us, but this now, this is an integral that we know how to do. So this is negative x cosine of x. And you know that the antiderivative of cosine of x is sine, so plus sine of x. And since it's really an antiderivative, it's plus c. And so that is the answer, right? I'm going to use the magic of television and check this work, right? So hopefully you'll see that it actually does work. So let's double check. Here's our answer we got in the previous example. Okay, let's take the derivative. All right, so remember the product rule. So here's a product rule. The derivative of negative x is negative 1 times the cosine x. And then we had a negative x, but then the derivative of cosine is negative sine of x. So when you put those together, that's where this plus comes from, right? So, and then what's the derivative of sine of x? It's cosine of x. Notice that this and this cancel each other out, and so we get x sine of x is our derivative, and then antiderivative working backwards is that. All right. Hey guys, I appreciate you taking the time to watch. I hope the integration by parts makes sense to you. We will practice it more in class. We'll see you then.